Hello, this is a quick introduction to Dr. Hill's YouTube tutorials on physics. This is Year 11 Physics, 2003, Epping Boys High. As you can see here is the physics data sheet, charge and electron. Don't worry if you can't see it at the moment, I'm just going to expand. Take this out of here. Make sure I can put it back correct position. Take our first problem here, which we can just set here. It says the diagram shows the mechanical wave. We've got the amplitude and the time in here. So it says the frequency of the mechanical wave, or the period of the mechanical wave, is the period of one cycle. So it's from here to here, and that's 6 minus 2 seconds equals 4 seconds, and period equals 1 on frequency equals 0.25 hertz, which is this one here. Which of the following statements about the transmission of sound is true? Sound waves travel faster in a medium where the particles are further apart. That's in general true. Sound waves do not require a medium to propagate. No, that's wrong. The speed of sound at sea level is this regardless of the medium in which it's travelling. Well, in helium it travels much faster, so that's wrong. Sound waves will generally travel faster in a more dense medium. Well, that's not necessarily, that can be true, but the heavier the particles, the slower they respond. We'll come back, so I'll give the answer there is A. Oceanographers rely on ultrasound to map the sea, the floor of the sea. It will be, ultrasound means very high frequency. It's very unlikely it's infrasound, or very low frequency. The transducer sends high frequency sound waves, well, they've said high frequency, to the sea floor. The time it looks back, the transducer is recorded. The principal record is not superposition, but not refraction. It could be refraction, but most definitely reflection. The reason very little information is lost when data is transmitted along optical fibres. The electromagnetic wave is totally internally reflected due to the high refractive index of the core of the optical fibre. That is a true fact, or not really. It's guided but not totally internally reflected. Optical fibres are coherent bundles, so that image received is identical to that which is taken. Now, that refers to an optical fibre array, and it's not necessarily a coherent bundle, so that's definitely wrong. Information is encoded digitally rather than analog format. This is very true, that information is lost when data is transmitted along the optical fibre. It's not very long, but little information. So digital means that you can have error correction, so this is definitely a good answer. However, amplifiers are used every 25 kilometres, more like 600 kilometres. So the signal does not decay according to the inverse square law. Well, the signal, that is also true, but that's not why information is not lost, it's because it's digital. Galvani believed that electrical impulses were generated inside the frog itself, which is what he believed. He actually didn't believe electrical impulses, he believed in animal electricity. Connection of two similar types of metal by means of a salt solution. Connection of two different types of metal by means of a salt solution. So let's see what's the difference. Of two similar, different, an external source to the frog itself. So the best answer is A, but he'd actually believe in electricity. The diagram below shows a positive and negative charge. The position where the electric field would be most negative. So E F equals EQ. Now, the electric field would be most negative. It's actually a bit confusing because the electric field is a vector. So it's not a scalar. So This is a very difficult one to say. So the electric field, I can't answer that one because that one says it's a vector. The electrical appliance, now just here, the electrical appliance is 1.8 amps times 240 volts. P equals VI. How long will it take the appliance to get, so energy is VIT, so 2000 on 1.8 times 240 is the amount of time it will take. Just takes over here and on. So clear that. 1.8 slash 240 equals 46 seconds. 46 seconds, that one there. Okay, that concludes this page. We'll see how we've gone so far.